Yes, good morning, everyone. You're welcome to our second class. I was unable to access my e-learning portal to get the link. It is Kakuru, the class coordinator, who has been able to send it to me here. So last time, we introduced this module. We looked at some of the things, what basically data science is, and the pipeline, the life cycle, the questions it helps us to answer, and many other things. Like I said, this module is more of hands-on. Today might be our last class for the theory because I want everyone to be muted. Right now, I cannot mute everyone because I'm unable to access the e-learning portal where I have the rights to mute everyone. So I request that we all stay muted. Now, Miss Derek, please mute yourself. We don't need to have any background noise from any of you. So I'm going to share my screen in a few. For our lecture too. I'm hoping you can see my screen.
Morning, Doctor. We can see your screen.
Okay, that's good. Now, data science, as the name, as you can hear the name, it's more to do with data. So before we dive into the other core aspects, we need to understand the kinds of data that actually exist out there. Remember, we said in our definition, using those mathematics from domain experts and other skill sets to be able to extract insights from data. But we need to understand which kind of data that actually exists out there. Okay. So we have these types of data that are out there. Of course, some of these things are very basic to you. We know what data is: raw facts, figures, or observations, or measurements collected for analysis, interpretation, and decision making. They are basically raw. They don't make any sense, okay, until when they are processed. So when they are processed, they become information. We all know that. So this is an example of this kind of data I'm talking about here. Now, the types of data here include what we call structured data, which is highly organized. So you as a data scientist, you'll be dealing with different types of data, okay? The first will be structured data, and this is the first we're going to look at when we begin manipulating our data sets to be able to extract a few insights. We shall begin with what we call structured data. That means it's highly organized and follows a fixed schema and is easily stored, searched, and processed using traditional databases. Some of the attributes of this kind of data stored in rows and columns. You can take an example of an Excel sheet. Everything is organized there. You have the rows, you have the columns. You have the columns which are fixed, and all the data sets are supposed to fit in within those specific columns. Okay. You also specify the type of data. They could be integers or numbers. Sometimes they could be strings, that means letters or characters or names, okay? Or also be a date. Sometimes also currency. You've seen how it works in Excel. It can easily be queried, and it is consistent and in a predictable format. And examples of that, for instance, in hospitals, the records, if you go to a hospital, they take your information and store it in their databases, highly structured: your name, your age, the illnesses or the symptoms that you are facing, blah, blah. They go in specific designated columns and rows within that storage system or that database that they're storing those things. Another example is employee payroll data, and I'm an employee of UTAM, and my records are in a structured format. My employee ID, my name, my qualifications, everything. So every employee, the information fits within that kind of structured, format. Very easily queried and can be very easily processed. Okay, that's another example of structured data. We have students record in a university database. For instance, your records that we have in our term systems, highly structured. You applied for the course and the information was entered into that database. Every applicant, every student here filled in the same form. And the form was collecting the similar information, just that they were kind of like placeholders. You could fit in information that is unique to you. But where there's a name, you put a name, the age and stuff like that. So as we proceed with this module, or as you venture into the practical data science later, maybe after your course, you understand that this kind of data actually exists and we deal with it most of the time. The other is bank transaction tables. You go in a bank, you fill up a form applying for a bank or to get a bank account. All your financial records are in similar forms, similar structure. What's going to vary are the actual variables, which are the information that pertain to different people who are having bank accounts and banking details. The money will be in the same format, but different amount. I could have 20K, you could have 30K. But all of that is currency, or the type of data that is fed into that kind of row. It's a figure, it's a number, So common storage systems, here we have RDBMS. I don't know, some of you I think have some background in IT. So we have RDBMS, or relational database management systems, such as MySQL. Okay, so these systems that we're talking about here store things in MySQL, or we can be able to create databases using MySQL, and we store them there. We have what's called Postgres SQL and Oracle. Even spreadsheets, Google Sheets, we've seen some of these highly structured. Okay, that's the kind of data that we shall first deal with when we begin processing or manipulating data sets later. The advantages, they are very easy to analyze and report, very efficient to query them, okay? And also, they have high data integrity. Limitations, the structure is very rigid, you can't easily modify it. Difficult to handle complex or evolving data sets. I'll give an example of things like live streaming and stuff. Those are constantly changing. You can't have them in an Excel sheet, because you can't easily modify them quickly because of the rigidness of how they were stored with fixed columns and stuff. The next type of data sets we shall be able to deal with is semi-structured data. This one does not follow a rigid schema, but it contains tags or markers or keys that provide structure. So unlike the ones that we have seen for structured, these ones do not follow a specific structure. Some of the features is, one, doesn't follow a specific table structure, but uses tags. We have what you call, in this example, on this second feature here, we call XML or JSON. JSON is JavaScript annotation. XML is extensible markup language. I don't know whether some of you have been able to use some of these. They look like HTML, but they're tags. I will show you an example later. These kind of data sets are machine readable, okay, and requires parsing. That means techniques such as NLP or natural language processing can be used to extract meaningful information for analysis from this kind of data sets. Examples, we have JSON. JSON is, because these are the tags, and information is stored there. For example, user ID, name, role, last login. I will give some snippets of how JSON works later, but we use it in storing data sets. I will give an example of log files. I'm also into cybersecurity. How we store log files is we store them in JSON sometime to be able to extract them and be able to process and analyze them and find out which kind of anomalies exist in this kind of data sets. So JSON is one of those. System log files as well. For example, all systems have log files, okay, that are being stored there, where we store some kind of data. For example, someone has tried to attempt to log into your system, a log file is stored there. how many attempts, 2, 3, 4 attempts, which attempts were successful and stuff. If it's about networks or computer systems, if there's an error and stuff, all the things are stored in form of log files. That is semi-structured. Email messages as well, and even XML documents. I've just told you about it. They look like HTML. We shall see them later, but they look like HTML. But they have some tags that can allow us to be able to, uniquely extract the information that is there, which is variable, which can actually change, unlike the one we saw for the structured. Common types of storage, we have NoSQL databases like MongoDB or even CouchDB, cloud storage systems, and even log management systems. If in case you have a fully fledged system that has logs that are being stored there for any action that's being done, those ones are able to store this kind of semi-structured data. Advantages, they're flexible. They can handle evolving data sets. Okay. Of course, they use tags, keys, or metadata that make the data easier to interpret than unstructured data, which we are going to see in the next slide. Disadvantages, more complex querying. Because it's constantly evolving, it requires specialized query languages to be able to filter and query and fetch this kind of data from this kind of ways. It requires additional processing because it is semi-structured. You require other tools such as NLP. For instance, if you wanted to identify which emails are spam or not spam, we use NLP, by the way. These email providers use NLP to filter out which messages are spammy, which ones are not spammy, which ones are for marketing and stuff, how they come in. Because they are semi-structured, they require further processing to be able to be filtered out and organized in a particular way. And others. Then lastly is unstructured data. During my PhD, I was dealing with unstructured data. This one has no predefined format organization, making it very difficult to store and analyze using traditional tools. It is free form, it is high volume, very complex to analyze, and often requires artificial intelligence or natural language processing techniques to be able to process it. Examples are CCTV footage. I know maybe one of you will be saying that, why do you say it has no predefined format? Yes, CCTV footage could have a format, maybe MP4 or maybe MKV or whatever. But remember, the different formats that come into this require different ways of how we can process it, which is a little bit challenging. Okay, so it requires techniques that are AI-powered to be able to process this kind of data sets. Another example is social media posts. Okay, remember I just told you that they are in high volume. They are complex to analyze and they're in free form. If any of you wanted maybe take on a field of NLP to analyze sentiment or to analyze purchasing behavior of people on let us say Jumia or Amazon and stuff, you will see how data varies within those kind of formats or settings, such as Jumia or even Facebook, okay, even Twitter or X or whatever. Because they're in high volume, they require specialized tools most of the time, which are AI powered. Audio recordings as well, they're also a form of unstructured. Images and videos, of course, CCTV footage captures the video part of it. I was dealing with images during my PhD for image processing. Text documents, for instance, people who are lawyers, I will give an example, they are dealing with so much text messages. So that's high volume kind of data sets that have to be dealt with. You can imagine, maybe, of course, they could all be standardized using Microsoft Word, but in different fonts. Others are in PDF, others in other formats that are not easily, understood. But all of them are text documents, but then have to be processed. Okay, people who are setting up systems for processing documents, such as in the legal sector, they are dealing with enormous volume of textual information. in different formats, PDFs, text, Word, different fonts, different, all sorts of things. So this is unstructured. Then, of course, common tools for analysis is NLP. If you wanted to analyze videos or images, there's a field of computer science called computer vision. My PhD was in computer vision, where I was able to process images. These images come in different formats. Some formats probably I think you've never heard of them. I was dealing with extremely heavy images, where one image could have pixels of 10,000 by 10,000. We are dealing with mostly up to 1,000, maybe 2,000. Okay, but an image of 10,000 pixels by 10,000 is very big and also very heavy. So one image could be around 90 MBs or 90 megabytes. The images I was dealing with are basically remote sensing images, which are very big, and processing them required me to train some models to be able to detect which features I was really looking at here. So if you look at an image plainly, your naked eye doesn't give you all the insights, okay? Because our eyes have been made to understand images in a different way. But now AI tools or AI-powered architectures or neural networks, they can zero down up what they call the pixel level and tell you the different features that are out there that you can't even see with your naked eyes because of the limitations we have in our eyesight. So such datasets require specialized tools, most of which are machine learning based. So they're able to do this kind of thing for us, unlike other kind of datasets such as semi-structured and even structured. Advantages, they provide rich and detailed information. Okay, captures human behavior and context, such as the CCTV video or footage. They are flexible and in diverse formats, text, images, audios, videos, and even enables advanced insights through AI and machine learning techniques. I'll give a very simple example here. An image of a landslide taken from above, or you just see an image and you see some funny landforms there, but you might not see the extent of the landslide. But if I process it using my machine learning models, I can know even the length, okay, the height. I can even know to the pixel level, the extent of this landslide. For you will know a rough idea that, okay, the land was able to be moved from here to here, but you might not know in terms of meters, in terms of the radius, you cannot know. But I can train a model and it's going to analyze this image at the pixel level and it will tell me all those details, which you cannot do with normal datasets which are structured or semi-structured. Some of my friends during my PhD were looking at crop diseases, pests and diseases. You could identify a disease that is affecting a particular plant, of course, through the leaves, even before it spreads out. But how would you know that? For you would see a leaf and you would say, I think this leaf is normal. But I can take a picture of that leaf, I process it using machine learning, and I can tell that some other areas of this leaf are actually having some anomalous or anomaly, indications that point to the fact that there's a disease that is trying to spread on this kind of leaf. But for you might not see with your naked eye, but with computer vision, the tools, the machine learning and stuff, we can be able to process all these things. This kind of unstructured data has problems, very difficult to process. Okay, high storage and computational costs. So computer vision requires extremely expensive equipment. I will just give it into perspective. My university where I was, of course, they have enough funding for research. For me to process my data sets, it required a very expensive machine, which cost around 15,000 US dollars. 15,000 US dollars. That is RAM. It had RAM of 256 gigabytes of memory. It has 4 GPUs. It was a 14th generation computer. It had 4 terabytes of hard disk, and other specs that made it very unique for machine learning processing, which takes me back to our first class where I was telling you that some of these things in machine learning or AI and data science requires some of these gadgets, these machines. Some of the laptops around the market here, like gaming PCs or gaming laptops, are very good for machine learning or data science, activities because they have the GPUs. The GPUs allows them to render some of these attributes, such as text and images or videos, allows to process even up to unstructured data. They also have enough storage, by the way. And of course, these disadvantages make these builds very resource intensive, and therefore most people don't do things to do with this unless, of course, they have the resources at their exposure. Otherwise, it's very hard. So, which now takes me to another very important thing during our class here. Yes, as much as I want to expose you to some of these data sets, it might be very challenging for us to go to images. Maybe we shall go to that next semester if maybe some of us have been able to get access to some of these high-end PCs. We shall mostly deal with textual data, which is very easy to process. It doesn't require so much memory. That means even your dual core can do the job very easily. Okay, so yeah, those are some of the kinds of data sets that actually exist out there. This is the summary. You can look through the summary later. We also have quantitative or qualitative data. We've seen some of the things. I know they're going to teach you research methodology. Professor Junju, he'll take you some of these quantitative stuff. Okay. Quantitative is basically numerical values. Some of the data sets that we shall be working with are quantitative in nature. Of course, some of the ways we can analyze them are through statistical methods such as mean, median, standard deviation, and others. Okay. Then, of course, qualitative data, this is highly descriptive and very subjective. No, not this. Okay, yeah, descriptive, not subjective, but of course, descriptive in nature that it doesn't, the opinions that are got from one person's analysis varies from one person to another. That's the uniqueness of this kind of data sets, okay? They're subjective and they are context rich. The opinion I will have on the kind of data set that is qualitative will vary from one person to another. We can't have the same opinion because that's the kind of data set we're dealing with, such as interview transcripts, user feedback, focus group discussions, open-ended survey responses where someone has to write their own text and they have to come and read through and try to understand the context of how this person is able to, attempt or address the issue at hand. So yeah, those are the ones. Then, of course, common techniques for analysis, thematic analysis, content analysis. I know we shall not be able to do this kind of thing because people from the social science are the ones who deal with qualitative data sets mostly. For us, we shall be dealing mostly with quantitative. This is a simple comparison of these two. Okay. Then sources of data sets. Where shall we get this kind of data sets that we're looking for? The first source are databases. If you remember, when I was talking about structured data sets, such as in the banking industry, school, information about students, where do you get this kind of information from? If you're going to analyze, for instance, the performance of learners using artificial intelligence, where will you get this kind of data set? You have to go to a school, you have to go to a university and ask them. Sometimes you have to get permission, you have to get approval. And sometimes there's what we call the anonymization processes. Because some of the information might be highly sensitive, you might need to anonymize the individuals such that you cannot pinpoint who actually this individual is in real life. Okay. For instance, you're going to talk about health information or health data. You might have to go to a hospital. Now, health data is very, very sensitive. People don't want other people to know about their health status. In fact, in other countries, I'm sure it has been adopted by most countries. They can jail you for more than 10 years for if you have found that you have leaked someone's health information. Most people are sick, but you cannot be able to tell that they are sick. But if people know that they are sick, then there will be what you call stigma. People try to avoid them, and this creates social chaos, which governments are very much against, discriminating people because someone has HIV and you know that they have HIV. So we have to anonymize this kind of data sets. So for those of you who are thinking of probably thinking future, analyzing data sets from the health industry, understand one thing, that access to such data sets is very highly restricted. Okay. It requires approvals. Recently, we did a research, AI for maternal health care. We're looking at diseases that affect mothers, such as in cases of postnatal or prenatal, such as pre-eclampsia and other diseases. I can assure you, to get the clearance, it took us 6 months, and yet we had someone from the inside. We even had to pay money, $350 to access the data sets, and even, go through a methodological process of anonymizing those individuals and proving to them that the ones that we have been able to collect actually cannot pinpoint a particular individual. Okay, because you're talking about information about people, ladies or women who go for antenatal care, the kind of diseases that they have, that record all has their names and everything. So it was not very easy. So yeah, that is one of the sources, databases, because they're storing structured data, banking systems, schools, and others. For a use case here could be retrieving transaction histories for fraud detection. Maybe one of us might want to undertake a research to identify fraud in data sets using AI. So that means you might have to go to a bank, and also banks releasing this information regarding transactions might be also challenging unless there's a way you can anonymize some of the things, because they know if it falls in the hands of their competitors, they will know how they're doing and they can beat them. Okay. So some of the things are a little bit very tricky to get, but of course we can always get them once we have some process that we go through to get those kind of data sets. So that's the first source. Then another source is called APIs, because in our next class, we might have to look for data sets. So we might need to know where to get this kind of data sets. APIs, or what we call application programming interfaces. Now, these ones allow systems to communicate and exchange data automatically. I'll give an example. I know maybe some of us have an experience with APIs. I'll give an example of maybe Jumia. Okay. If Jumia wanted to integrate payments using mobile money to its system, such that people can, go to their carts, go to their, items, select them, add them to carts, go to the checkout, then you see the summary of the money, then the payment method, mobile money, Airtel money. Then you click on Airtel money because I purchased using Jumia. Then you are there, after clicking Airtel money, then the number goes in, then you wait for the USSD prompt to come on your phone, then you are putting your PIN code and money is deducted. Mobile money, either MTN or Airtel, those are different systems. Jumia is another system altogether, but these systems are able to work together. So how come you are able to set mobile money payment using Momo, and on your phone, a message came up and you put in password? How do these systems actually work together? There's what we call an API. So the owner of for instance, in this case, it is Airtel Money, which has to be integrated into different platforms for payments. So Airtel Money or Momo have what we call an API that they build. This API allows their system to work with our systems to execute payments. Okay, so they harmonize what we call data formats. Then the two systems can communicate via a single interface. Another example I can give you here is the school pay system. You pay school fees using school pay system. So there are formats which have been agreed on by the school pay together with the system that they're going to communicate with. So that means you need developers in place to ensure that they can harmonize these two formats of datasets such that they can allow you to be able to collect this kind of datasets. I'll give another example. Assume you wanted to collect information about weather forecasting. Okay, maybe we're seeing information on TVs that, okay, tomorrow it might rain. How do you think they're getting this kind of information? There's an API that is actually allowing us to collect this kind of data sets from the meteorological department. Then we can now put it on our websites, we can put it on our other platforms, and they come in real time because the formats have been agreed upon. Okay. Social media APIs, you want the feed of Twitter or X, in this case, Facebook, to appear on your website. So you're going to have to get that API, which is already there by the way, and integrate it within your website, and the feeds will be coming on your website. And whichever time you post anything on your X or Facebook, it shows on your website. So APIs are one of the ways we can also collect data sets. Okay. If I wanted, for instance, to access records of students from UTAM for my research, one of the ways I can do is to go and ask for this information and they export it for me. Or in case the university has an API, they can be able to share the formats of data sets and I implement it where I am over my system and I can collect this kind of information. For example, if I wanted to find out how people are able to access our links and log into our systems each time there's a class, that is information that is real time. Either I can pick the logs or I can have an API implemented and my system be able to collect all the attempts to log into the system each time someone tries to click on a link or log into the e-learning portal and access the link. So that's the way we can also be able to collect data sets. And it's very much easy in case you have a developer who can study the code, because most of the time the code is in a language that is object-oriented. So that means that the individual should have skills in object-oriented programming to see the different kind of systems that are out there and that need to be able to communicate with one another. Because my system could be developed in Java or maybe C# or Python, and the other system is in C++. Okay, so that means that this person must be able to implement what we call the CORBA architecture, the Common Object Broker architecture, where you harmonize two systems, you put together the different formats of data sets, you test out a system, and you see that if you send a message from this system, it reflects there on the other system immediately. There is no time, it's instant. So that's the second source of data set we can be able to get as well. The other one is called open data portals. Now, sometimes you might need to have access to government data sets. I'll give an example of UBOS. Maybe you want to find about population statistics. I know they gave us some fake results a few years ago when they did their census, but let us assume it was legit data set that they were able to collect. So some of these kind of data sets are published on their portals for public consumption. And in this case, you don't need any permission. For instance, the kind of data sets that they collected recently from their census gives the entire demographics about the population of citizens in the country. You can know how many people are lame, how many people went to school, how many people stopped at the university level, the number of families, the number of people in the families, how many are employed, who died, blah, blah, all this kind of information. It's so much rich. So you can get from their website. You don't need to go and ask for any approval because this is for public consumption. Okay. So sometimes even NGOs, for instance, you want to find out the performance of we call them interventions. Maybe the NGO is supposed to publish a report, okay, about its intervention, maybe constructing boreholes, maybe putting up structures for displaced people. You can map all this kind of information maybe on a map, and this information is sometimes available on their websites. Even other research institutions also have some of the things published there. An example here is the National Bureau of Statistics, the World Bank Open Data. If you want to analyze global trends to do with financial institutions and their interventions, like at the World Bank stage, then you go to the World Bank Open Data portal is there. United Nations High Commission for Refugees is also open there, free. So in case you want to analyze those things, you go there and be able to download them. Now for my case here, I used what we call Copernicus Data Repository, which stores satellite imagery of the whole world. So me, I was looking at data sets to do with forest change in Brunei. Brunei is the country I was studying from. So I went to this Copernicus and I was able to select my years, and then I was able to download those images free. Then I was able to, process them, clean them, and I was able to, build a model that allows me to understand the different patterns of forestry or forest changes across a given area in Brunei. So yeah, those are some of the other open portals that you can be able to go to and access this kind of data sets. We also have other sources apart from these ones that I've been able to put here, such as data repositories that are out there online. We have what we call Cargo. I don't know whether any of us has been able to access systems such as the Cargo. Cargo is where most data scientists actually go. We go there looking for data sets to play around with and be able to learn how things actually work there. We have Cargo, we have GitHub, okay? And some of my experiments are there on GitHub. So I'm able to go and access them from there and be able to play around with them. We can even fork some of those codes that are out there and be able to play around with them very easily. So Cargo is also another area we can also go to in case we're looking for data sets. In fact, I use Cargo most of the time to be able to access different data sets and play around with them. Even competitions are there. Those of you who might be into competitions, and by the way, the people win money there for your information. People win money. Cargo data sets that are out there for competition. People go and participate, write their code, and show their accuracies and stuff. Okay, so they're able to get some money from there. Okay, so Cargo is the best option for us. For starters, we can look out for different data sets on Cargo, and we're able to, play around with those data sets and learn a few things. Other sources are from sensors and IoT devices. IoT means Internet of Things. These ones are also storing data sets. And because they are internet-based, some of the data sets or data is stored on the cloud in form of JSON and other formats. Surveys and questionnaires, web scraping. Now, web scraping has now kind of died slightly because of LLM, large language models such as Cloud. Okay, so ideally, what we would do here, we call it RPA, robotic process automation. You can write a simple Python code that can automate my browsing. For instance, if I'm looking for papers to research about, I can write a simple Python code. I automate it, and it does everything for me on my computer, and I'm just there, clicking around, searching for articles that I've given it some keywords, then downloading those articles in case they are downloadable, storing them in a particular folder. But right now, there's Cloud. Cloud is one of those giants in generative AI using LLMs. Now they are very much powerful. They are called their MCP, Model Context Protocol, that we are now trying to implement to see that we can customize it into what we call the agentic AI. You're building micro LLMs, agents to do things for you. Okay, you don't need now web scraping or those other RPAs that we used to do some time back. Okay, so we don't need those anymore because there's MCP now with cloud. Of course, it is paid for. It depends on what you want to do with it and what value you want to gain from using the MCP from cloud. Yeah, but it's worth the investment because it is simplifying most of the work that we're doing. These tools are supposed to be embraced. Okay. So in a nutshell, those are the kind of data sets that we have. And before we start on our next class, we are going to be able to dust off some of our skills because we're going to dive into some of these practical stuffs moving forward. I know some of us don't have the Python background. I'll put for you some of the resources here. Okay. We are going to have to learn Python because I use Python. You can use any editor that you want, an environment. I use Anaconda because everything is there within Anaconda. And within Anaconda, I use my Spider as my environment where I can write my Python code. You can use Jupyter Notebook. Okay. Can use tools such as the VS Code. Okay, the Visual Studio Code, Microsoft VS Code, it's also very good. You can use PyCharm. There are very many. So those of you who don't have Python skills, I put for you this link here. Let me first stop sharing here and I show you a few things because we need to have some skills before we can be able to proceed. I'm going to share my screen here briefly just to show you what I'm trying to demo here briefly. Let me share my entire screen such that I can easily switch. So some of the resources I've given you here, I learned my Python through some of these sources. I'll take you to this video here. This guy is an Indian guy. This guy taught me Python. Okay. So in case you are out there.
Hey guys, my name is Srini.
Okay. And this guy here is a very good guy in teaching and he's a physicist. He's not even a computer scientist, but he's a very good teacher. He taught me how to code in Python. These are his videos. Okay, of course, starting from around somewhere, I think around this one. He now began to talk about images because now my PhD was in images. So I went through the images stuff here. Okay. But of course, I want us to learn from those of you who don't have the Python skills. You can begin with this guy here. Okay. Can learn from there in case you want to use Jupyter Notebook. You can also use this link and even other resources on the web. Okay. So it becomes very much easy. I use Anaconda for my Python as a tool, but of course for my classes, I'm not going to use Anaconda because Anaconda has some dependencies, some of which I don't want to go through with you guys because all of us are in different settings. My Anaconda is opening, just hold on. We're in different settings and sometimes because of the different plugins and stuff, setting up environment variables, this could be challenging for us, wherever we might be. So what I will choose to use, I'm going to use what to call the web version of Jupyter, which runs on the browser. I can also have it on my Anaconda here because it can run as a local host, but I'm going to use the browser-based version because it doesn't have so many dependencies. It becomes very easy for me to teach some of these things. But still, it depends on which tools you want to use. So this is Anaconda opening up. It has very many things. It's a heavy program for information. So that's why you see it takes some time. So this is Anaconda. It has different tools you can use for coding Python. There's PyCharm. Okay. There is Jupyter Lab is here. I already installed it. There's Notebook also, I installed it. There's VS Code. I use Spider, okay, but you can choose to use the VS Code. You can choose to use Spider. I'm very comfortable with Spider. It even has other things here for visualization. For example, like the orange. It even has others. RStudio. Those guys who are into the R programming. Okay, they can also use this and others. Okay. So you can choose to go whatever that you want to learn your Python or even code your Python. Me, I will be using the Jupyter Lab and the web version of it because I can comfortably be able to explain a few concepts very easily from there. Then having everyone installing Anaconda, some of us might be having not so good strong machines. So therefore, Anaconda might weigh heavy on you because it is resource intensive and might not be a very good thing for you. But I prefer Anaconda for one reason, because it allows me to create environments. Some environments, for example, here I have two environments. I have the UTAM data science, this one here, and I can install there some of my, libraries that I want to use. The beauty with setting up environment is sometimes you're building or you're working on implementation that require different versions of Python. Okay. If let us say I wanted to use Python 2.9 for my experiments, it becomes very easy for me to create an environment where I can be able to work with Python of that kind of version. Okay. That's the beauty with Anaconda Navigator. I can be able to create multiple environments for multiple versions of my plugin that I'm trying to work with. But for starters, of course, you can use the web version of it, which I think is okay. But then if you grow out and become a serious data scientist, you understand what I'm talking about here, that you might need to have multiple environments for multiple tasks you're working on. Because sometimes some Python code you're working with require a different version of Python and other plugins, sometimes lower versions. So if you have same environment, then you're going to have conflicts. So sometimes we open up your code, today it's working and tomorrow it's not working. You're like, what happened? But if you have different environments, it becomes very easy for you to do what? To separate them and be able to work on each project in its own environment. So use these resources to go and dust off. Okay. If you want to install Anaconda, there's this video here, but of course you can go to Anaconda, the homepage, Anaconda. You can now be able to get everything from there, to download and stuff. All the things are there. Okay. So yeah, that's it. We have literally ended the theory part. We are going to begin some hands-on stuff in our next class. So we shall begin with the basics. We shall begin, of course, the key thing here is to have access to datasets. I will give you some sample datasets we shall be working with in our practice as we go along. But of course, you need to have access to these repositories where these datasets can be stored or can be found, such as Cargo and others. So that brings us to the end of our class today. In case there are any questions, please feel free to ask. Otherwise, we are going to start right away in our next class and see how we can be able to move on with the data science stuff. Any questions? I did not have time to get to know our backgrounds. Probably, I think some of us aren't from IT. It becomes a little bit challenging because there's a course in machine learning. I think it's taught by Danish. There's a colleague, Dr. Danish Azamuke, who will take you through that. Me, I'm not going to teach you Python. Me, I'm going to use Python for data science activities. So in case you don't have these skill sets, please take your time. You have a week. I know some of you might say a week is very, very small. Maybe some of you are working. But if you can dedicate time, if you can go through this guy's videos, have all the tools installed, and learn along with him. Trust me, by the time we meet in our next class, you might have some basics of how to code in Python. Those of you who don't have the Python skills yet. So one thing I want to emphasize here, you'll have to do some of these things as self-learning, such that you can get on board very fast. Okay. So go learn a few Python basics, along with those that Dr. programming by Dr. Stewart. He will be teaching programming for data scientists using Python. Then machine learning is taken by Dr. Azamuke. He's also an AI researcher. And yeah, all these things are providing with a holistic picture of the entire life cycle of a data scientist. So we hope by the time the course or the module ends or the semester ends, you have probably mastered the pipelines of how we can be able to prepare, process, and analyze different data sets. Any questions? So, Anthony, you seem to have a question.
Yes, mine is a request, a kind request, because yes, like you've said, some of us do not have a background in IT.
Yes.
Personally, background is in engineering, but civil. And my kind request is that as we move forward, that is also taken into consideration that we might not, even if we do self-learning, even if we source this information elsewhere, and we try to catch up, we might not really be on the same page or at the same pace as our colleagues who have that background already. So my kind request is that as we move forward, that is taken into consideration, so that at the end of that, we also finished products like they are. We've benefited from the program, and we can do many of these things by ourselves.
Sure. I want to bring it back to you that it should be the commitment on you. Okay, it should be an effort on you. I can do my best, but of course I can't be able to ensure that all of us are on the same page. It might be very challenging for me to guarantee that, but it comes down now to you. Now that you know the entire task ahead, if you're lacking some of these skill sets, please go start. I've shared some of these. I'm going to share these notes, this lecture slide. I'm going to enable it on the e-learning platform. Please start. Okay, that will be very good for you. Of course, I'll be also available for any support, but like I've said, Dr. Stewart will be teaching you the programming for data scientists. You'll be using Python. Then, of course, machine learning will be taken by Dr. Denish Azamuke. Frank, you seem to have a question.
Thank you very much, Prof. Mine is similar to the previous one. I come from the social sciences and with no prior background on computer science. When you speak, I understand whatever it is you are saying, but then the challenge is trying to do that which you speak, trying to put into action or into practice. And that's a very, very big challenge because the terminologies and the concepts are way, way too different. We're a bit struggling, and it's not a piece of cake. So sometimes we will have to take us slow, especially coming forward, and don't get tired. We will be coming back and forth to you in case we do not understand or we get stuck. I know with computer stuff, the more you try and fail, the more you learn. So we'll keep learning so that we can perfect and make this better. When you speak, I really follow, but to get to the actual practicalities, I think we're going to have to do a lot of learning, very fast learning, and
yes,
forward to it. Thank you.
The key word here is fast learning. Actually, some time runs 3 semesters. We basically have 12 weeks. If now this is the reality. If I say that I'm going to crawl very slow, I might end up not achieving the objectives of this course, which is why there are other components that piece together the entire picture. Components such as programming for data scientists by Dr. Stuart Semoju and machine learning. All the things along with mine, they'll piece together the entire the entire cake for you. Still, it means you have to do so much of self-learning. Even if Dr. Stewart teaches you programming, you'll also learn one thing, that not whatever is going to teach you in class is going to be enough. You will still have to go back and teach some of these things by yourself. I'm seeing some people here in the want among the participants. Some of them are good Python programmers, such as Nsubuga, Hassan, such as Sega Abdul Karim. These ones can also help you out, and you can be able to form some groups offline, off class here, and you can also consult with them, and they can teach you some of these things quickly. That is if they have time as well. But like you said, there will be some fast learning from your end. So if there are no any other questions, I thank you so much. We are going to catch up. Please take my my key takeaways very serious. Go and do some self-learning. Go and use the resources I've shared. I'm going to enable this on the e-learning portal. You can access this slide for this class and be able to prepare, because we are going to start in our next class. Of course, I will start with the basics. I'm not saying I'm going to start with the hardcore stuff. No, we'll start slowly, because we have to build the skill set starting from the first principles. I'm not saying I'm going to begin with those tough things. No, we'll go slowly, because there are other courses that are going to come after this that are going to also help you build the skill sets. By the time you finish the course, you'll have gotten the value for your investment in this course. Frank, you still have a question before we go?
It's about the class activity. I forgot some of the two references which I used. I just figured out that I didn't include them in the bibliography. Can I withdraw and resubmit?
Yeah, let me do that right after this class. I'll enable the submission up to the end of today.
Okay, please.
Okay, guys, thank you so much. See you next week.
Thank you and have a nice day.